So we're in your chemistry book in section 2.4, and we're going to be talking about the atomic number, the mass number, isotopes, and ions. So you need to know what all of these are, and they all have to do with atoms, right? Atoms and molecules. And so let's start with the atomic number. So what is the atomic number? Well, the atomic number is the number of protons in the nucleus, and it determines the identity of an element. So the number of protons, like if you have hydrogen have one proton, then you'll have a hydrogen atom. If you have two protons, you'll have a helium atom. If you have three protons, a lithium, and so on. And an atom like 82 protons would be lead. If you do not have 82 protons, then you will not have lead. So the atomic number represents the identity. So if you look on a periodic table at your elements and you look, you'll find out the identity by the atomic number. So atomic number is very important, and just know it represents the protons in the nucleus. The atomic number is often given with the symbol Z. So whenever you have the symbol Z here, it means atomic number. Now that's going to be a little confusing because the next number is going to be A. And I get confused sometimes by the Z and A. Just remember Z, protons, it has to do with the protons. Why they gave it a Z, I'm not sure. But all atoms of the same element have the same number of protons and hence will have the same atomic number Z. So instead of A, we have Z as its symbol. So now let's talk about the mass number. The mass number is those both protons and neutrons in the nucleus. So the mass number is the sum of the protons, which is the atomic number, and then some extra neutrons that are in there in the nucleus. And both of these protons and neutrons are called nucleons because they are in the nucleus of the atom, which is the center of the atom. Thus, the mass number may be identified as the total number of nucleons in an atom. So here is A. A means mass number. So that's A meaning the not atomic number. So that's kind of confusing why they did that. But Z is protons and N is neutrons. So it's going to be the mass number equals protons plus neutrons. Now, when you think of mass number, it's not really the mass number. Why? Because electrons do have mass, but their mass is pretty negligible. They're so light. So the mass number is approximate of the atomic mass because the heaviest particles in an atom are the protons and neutrons that are in the center of the atom, and they're the heaviest. So mass number, that's the mass number, not the atomic mass, but the mass number. So we have protons plus neutrons. So now we're going to go down to isotopes, okay? Let me go up here a little bit. Sorry. Isotopes. So we're going to talk about isotopes. Whoops, let's get it right here. Isotopes. So what are isotopes? Well, atoms of the same element do not always have the same number of neutrons. Now remember, if you have 12 protons, you are going to have a carbon atom, right? But a carbon atom may have 6 neutrons or it may have 8 neutrons. So basically when an atom has of the same element has the same number of protons, but then they have an extra number of neutrons, this is called an isotope. So basically isotopes are atoms of an element that have different number of neutrons, like carbon having 6 or 8. Other ones have 2. You might take mass number of lead. Lead may have 206 or it may have 208 or a different number of lead. So it depends on that. So lead could be, 206 or lead 210. So that means it can have basically four more neutrons in the type, but it's still the same number of protons. So you get it? So let's look at this. Let's see, the specific isotopes of an element are symbolized using the general, see this form right here? AZ over X. That means we're going to go with the atomic mass divided by the Z, which is the atomic number, an X. And so that's how we know. And you'll find this on the periodic table. So like, let's see, right down here, like lead is 206 over 82. And so this, the 206 represents the mass number. That means protons and neutrons. And the 82 means the Z, or the protons. So you can look at this and right away you can say lead has 82 protons and it has 206 protons and neutrons. So find the number of neutrons. You just subtract 206 by 82. So here we have the number of neutrons. Here is basically to find the neutrons, we take the 206 and then you subtract the 82, so you'll get neutrons are 124 neutrons. So you'll see those different isotopes. All an isotope is a certain element that has extra neutrons. They might have, neutrons of 206 or 210. You can find out, but they have a different amount of neutrons in there, although they're the same element, right? So let's go on then. Let's look up here at these. I hope you can kind of see this. Let's kind of got this kind of crooked here. Up here in the corner. So you'll see on the periodic table 20 over 10. And then you'll see neon. So this is neon 20, so because it has a mass number of 20. And this is neon, and it says 21 over 10, so it's neon 21. And this is neon 22, because it has 22. So the mass number, of course, is 20, and 21, and 22. Now the atomic number, this is always 10, 10, 10, 10. Otherwise it would not be neon. So these are all 10, right? So now to find the number of neutrons, you're going to subtract, 20 minus 10, and you'll get 10 neutrons. 21 minus 10, you'll have 11 neutrons. And then 22 minus 10, and you'll have 12 neutrons. So we could find the number of neutrons. So you're going to be doing tables like this. These are kind of fun because basically it's very easy to find neutrons by just subtracting the mass number, the atomic mass number, by the number of protons, and then you'll get the number of neutrons, okay? Those are isotopes. They just have a different number of neutrons, right? Just remember, isotopes, different number of neutrons. Now we're going to talk about ions. So what's an ion? Well, ion is a charged particle. So it is an atom that has the number of electrons are differing. So the atom has a charge on it. It can either be a negative charge or it can be a positive charge. So an atom with a negative charge, and I love the way they put this here, anion is called a negative one. Just think of the N's in it. Negative. So an means negative. Ion is negative. So an ion with the fewer electrons than protons, so you have a positive charge, will be a cation. So an anion, a negative charge, means it has some extra negative charges. And what are negative charges? Electrons. It means it has more electrons, and so it gives it a negative charge. Now, if it has less electrons than protons, it will be a cation. When I think of cation, you think of positive, a cat with a positive smile, a cation, right? I always just remember, look at this. So you'll remember that anion is always negative. Cat is always positive, like the Cheshire cat smiling, it's positive, right? I don't know how to remember that, but this is a good way of remembering it. Just remember, ions are charged elements, or charged particles. Most molecules and most elements are neutral. They're not charged because the electrons balance out the protons. Protons are our protons are usually positive, and then negative are electrons. Just remember, that's why most of our atoms are balanced out, because they have the same number of electrons as they do protons, and that balances. But every once in a while, you'll have an electrically charged ion that will either have one extra or many extra. It'll have extra electrons, making it negative, or it have not enough electrons, making it positive. Okay? So let's go on to the next here. So going through these pretty quickly. Ions. And so to write an ion, you'll see here, like if you have written in the upper of the element, you'll say a Cl. This is chlorine. And see that little negative sign there? That means it has a -1. So if this was like oxygen here with 2 negative, it means it has 2 extra electrons, right? So basically, if the magnitude is just 1, the number is omitted. It would just be like this. But an oxygen atom may become an ion with a charge of 2 negatives by gaining 2, like 2 negatives. Both the chlorine 1 negative and 2 negative are anions, right? Because they're both negative. Now, let's go to the positive one. A sodium atom may become positive charged by losing 1 electron. They lose electron, they have less electron, they will be positive. And so the symbol is basically, here we have sodium is going to be positive because it lost electrons. It has less electrons than protons, so it's a +1. And you'll just put a positive sign. A calcium atom that loses 2 electrons to form calcium will have a 2 positive. So, and both of them are cations, they're positive. Okay, let's go on. In neutral atoms, there are an equal number of electrons and protons in neutral atoms. So you won't have a negative charge or a positive charge. An atom that loses electrons, an atom that loses electrons has more positive charged protons. So it all goes by these electrons. If they lost electrons, then it gives it a positive. If it gains electrons, since electrons are a negative charge, it's going to be negative. Okay? So that's pretty important in all of that. So now we're going to go, and they're going to give us an example here, some questions, and these shouldn't be too hard. And question, let's see, 2.1 says, write the nuclear symbols for isotopes. Isotopes have, remember, they have a different number of neutrons of silicon, having 14, 15, and 16 respectively. Okay, let's look down here. We have, let's see, every isotope of an element, silicon, has 14 in its nucleus. We could find this 14, Z, which is the atomic number. That's how many protons. To obtain the mass numbers, add 14 add 14 to the number of neutrons, because this is 14. So write the symbols for isotopes. So we have 14 plus 14 equal 28. So the mass number will be 28 because it has 14 protons and 14 neutrons. 14 neutrons. And now the next one will have an isotope of 15. So basically, we know silicon has 14 plus 15 equal 29. And then 14 plus 16 equals 30. So that's the symbols, and this is the symbol for silicon. You can get this on your periodical table, and it's in the back of the book, and it's SI. And so we put in the beginning, or put in the top number here, that's the mass number, which is 28, and then the Z number, or the atomic number, the number of protons is 14. So silicon 29 over 14, and silicon 30 over 14. So these are how you write it. So when you have this here, the first thing you have to look up silicon and find out what the proton number is, the atomic number, proton number is, and then add that to the neutrons, and you'll get the mass number, so it'll be 28 over 14. See how they did that? It's not really that hard, to do. So this going on here, it says the number, now we have how many protons and neutrons and electrons on each one of these. So I hope you can read this, but this is argon, and it says 40 over 18. So we have argon 40 over 18. We can just look at this here and we know there are 18 protons, and that's what makes it argon, 18 protons. And the mass weight is 40. So how do we find the neutrons? You just subtract 40 minus 18, which equals 22. So you find it has 22. It will have 22 neutrons. Let's go down and show you better on here. So we have argon, 40 over 18 here. And so it has 18. This bottom number is the number of protons, which make it argon. And then you have the number of neutrons would be 40 minus 18, which is 22. So how many electrons will we have? Well, we look up here and it is not, as you see, it's not a positive or negative, so it has to have equal number of protons as it does electrons, so 18. So argon will have 18 protons and 18 electrons because it's neutral. Okay, let's look at carbon. Carbon 14 over 6. So here we have carbon 14 over 6. How many protons? Right here we know protons is the bottom number here. That what makes it a carbon, 6. 6 protons. How many neutrons? Well, then we have the mass weight being 14, so it has to be 14 minus 6, which is 8. So it's going to have 8 neutrons. Well, how many electrons? Well, it's not positive or negative, so it has 6. 6, same number as protons. Protons and electrons are the same. Now let's look at iodine. Now this is a negative number, so that we're going to have to think about this. So we look on here, how many protons does it have? Well, 53. We know 53 because that's the atomic number there. So the Z number. And so now we're going to look at the mass number is 131. So we want to know how many neutrons. We just subtract 131 minus 53 and we get 78. So it's 78 neutrons. How many electrons? Well, if they were equal, it'd be 53, but they're not. There's one extra electron because one extra negative charge. So we have 53 protons and we have 54 electrons to make that a -1. So not too hard, huh? So let's go on. So that's going to be, let's go on to the section review here. See if I can do this quickly. Okay. First of all, let's say, what is the characteristic of an atom that determines its identity as a particular element? So what makes an atom its identity? It's the protons. Protons give its identity, or the atomic number, which is protons. What is the term for atoms of the same element that differ in their mass numbers? Isotopes. Isotopes may have different number of neutrons, which make the mass number different. What is the term for an atom or molecule that has an unequal number of electrons and protons resulting in a charge? These are ions. If they're charged, they're ions. Okay? So let's look really quick at this table here, and we can do these pretty quickly. You could probably do them in your head. So here we have helium, and we see, first we want a number Z, which is the number of protons we see is 2. And so we look at helium and we see the mass number. This is the mass number, which is an A. That would be 3. 3 is the mass number. So how many neutrons will it have? Well, 3 minus 2, that's how many neutrons it have. So how many electrons will it have? Well, it's 2 plus. That means it's missing 2 electrons. If it were equal, it would have 2 electrons, but it's missing 2 electrons, so it has 0 electrons, and it has a positive 2 charge. Okay? So let's go on to the lead. So if you look here at lead, how many protons are on lead? The bottom number is protons, and that's the Z number. There's 82. So, and it's not charged, so it has the same number of electrons, so it's going to have 82 electrons too, right? So, but how much will be the mass number? Well, you're going to take the first of all, let's go. The Z number is 82. The mass number is going to be 207. How many neutrons it's going to have? 207 minus 82, which equals 125. So it'll have 125 here. So 125, which would be 207 minus 82. Number of electrons, it's going to have the same number as protons, which would be 82. There's no charge on this. So okay, so let's go on to the next one. This one, B. Z number would be 5, number of protons. Okay, the mass number is going to be 10 here. And so what is the neutrons? It's going to be 10 minus 5, which will be 5. The number of electrons is going to be 5, because it's the same number of protons, be 5. And so is there electrical charge? No, the charge is going to be 0. So let's go on to this last one. On this one, you have, this is silver, right? Ag. So we're going to have Z number is the protons is going to be 47. Right here, this number 47. So this number will be 47. And the mass number is going to be 109, the top number. And so the neutrons is going to be 109 minus 47, which is what? 62, right? 62. The number of electrons. Okay, you're going to have less electrons because it has a positive charge. So electrons, if we had 47 electrons, it would be neutral. But we need less. So we're going to have the number of electrons are going to be 46. And it'll have a charge of +1. So let's look at that. See if you can look at that. I'll move this here so you can look at what I just did. Sorry. Right here. Okay. So this is what I just did here. So we have 40 over 18 argon, 18 protons. We have electrons. You're going to have 18 electrons. How many neutrons are you going to have? You're going to have 40 minus 18, which is 22 neutrons. So let's take the carbon here. 14 over 8, which means how many protons are you going to have? Or the Z number is protons, remember? 8. Right there, protons are 8. Neutrons would be 14 minus 8, which is 6. Electrons, since it's neutral, are going to have the same number as protons, which would be 8. Iodine here, again, there's going to be how many protons? 53. 53 protons, because this is the atomic number, the Z number. Neutrons are going to be 130 minus 53, which equals 78 neutrons. Electrons are going to be 53 plus, because it's a negative here, that means it has extra electrons, so it's going to be one more electron. It's 53 protons, it's going to be 54 electrons. So, okay. We did the silicon thing, how you do this. Silicon, you have 28, 29, 30. That's the atomic mass, so 28 over 14, silicon. These are how you do the mass numbers. We did that already. So, and we did these too, but let's go over these a little bit better here. So we have 3 over 2 helium plus 2 charge plus. That means 2 positive charge. So the Z, which is the atomic number, is 2. The mass number, the top number is going to be 3. That's the atomic mass. And then the neutrons are going to be 3 minus 2 equal 1. And because it's 2 charges, if it was equal, it would be 2 and 2. But because it's 2 less, I mean, basically, if it's 2 less, so it's going to be 0 electrons, and it's going to be a positive 2 charge. I kind of did that already. And this here with lead, 207/82. So we have the atomic number is going to be, the protons are going to be 82. The mass number is 207. And then the neutrons are going to be 207 minus 82, which are 125. And the electrons, since there's no charge, are going to be the same as the protons, 82. And it's going to be a neutral charge. So here we have B here, beryllium, I think it is. Anyway, and it's first of all, the Z number is going to be, the protons are 5. The atomic mass is 10, which is the A number. The neutrons are going to be 10 minus 5, which is 5 neutrons. And how many electrons? The same number because it's neutral, 5 electrons, neutral. Same with the silver, and I think we went over this already. I'll go over it quickly. The Z number is going to be 47. The A number, which is the mass, is 109. The neutrons are going to be 109 minus 47, which equals 62. The electrons are going to be, because there's one positive, that's going to be one less electron, right? Because electrons make it negative. So instead of 47 as the proton, it's going to be 46. And it's going to have a charge of +1. We did helium. So let's see here. Oh, here's silver, but it's 3+. So let's see. The protons are going to be, which is the Z number, going to be 79. The mass, the weight's going to be 191. We know that. And so the neutrons are going to be 191 minus 79, which equals 112. And then because it's 3+, this is the hard part, because 3+ would mean it's 3 less electrons to make it positive. So 79 minus 3 is 76. There'll be 76 electrons, which give it a charge of 3, +3. So this one here, I kind of skipped here. Iodine, the one of iodine, you had to figure this out. So first of all, iodine, we looked in here, the thing that was said, it said is 126. We looked up 126 of iodine and 126, and we found out that iodine has 53 protons. And if it's 126 minus 53, we have 73 neutrons. And because it has a +1 charge, it's going to be one extra electron from 53 to 54. So it's going to have a charge of -1. I put basically -1 there. The last one is, okay, we look here, we wanted to find out what number, so we had to look on the periodic table. It had this number 16, so we look on 16 on our periodic table and we see it's silicon. So we put down silicon. Well, there's 16, and then there's the atomic weight. Well, we didn't have atomic weight. We had this number 20, which would be neutrons. So we add 20 plus 16 and we get 36 would be its atomic weight. And then from that we get how many, we have a -2 charge here. So basically this -2 charge will have 18 instead of 16, which gives it a -2. So that's kind of hard because it basically says here, and this is the problems in here in your book. So but anyway, to figure it out, you have to look at the periodic table. Okay, so let's just see. Write the symbol for the isotope of each of the following elements of silicon, and we know how to do that. You can look these up and do them. Let's see if I did them. Maybe I didn't. Let's see. Anyway, let's go ahead and stop there.